There are rules to evolution. Every civilization in the galaxy understands them. We teach them in our academies. We record them in the ancient archives of the Galactic Assembly. They are the quiet laws that shape every intelligent species that has ever risen from the dust of a living world. Life begins in chaos. Then it stabilizes. Worlds that nurture intelligence are gentle places, calm oceans, mild climates, ecosystems balanced by time itself. Species born there evolve slowly, carefully, predictably. Their path toward technology is measured across millennia. Worlds that are violent, unstable, and hostile rarely produce intelligence at all. Predators dominate. Extinction is common. Evolution resets itself endlessly. These are not theories. They are facts observed across thousands of civilizations. Or at least they were, until we found Earth. I remember the first time its data appeared in the Assembly archives. At first, it looked like a mistake. The gravity readings were wrong. The atmospheric volatility was impossible. The ecological balance made no sense. Earth was classified as a death world, a planetary category so dangerous that intelligent life almost never survives long enough to develop technology. Its oceans churned with storms powerful enough to swallow entire continents in rain. Its tectonic plates shifted constantly, triggering earthquakes and volcanoes capable of darkening the sky for years. And the predators. By the stars, the predators. Teeth, claws, venom, speed. Entire ecosystems built on violence. The scholars reviewing the data assumed the planet would host only primitive organisms, small, cautious creatures hiding from extinction beneath the shadows of stronger beasts. Instead, the dominant species was human. At first, we believed they were anomalies, perhaps an emerging intelligence that had not yet faced the inevitable extinction that hostile worlds eventually deliver. But then, we began studying their history. And that is when the confusion began. Humanity did not evolve gently. They evolved through catastrophe. Ice ages buried their world beneath kilometers of frozen oceans. Meteor impacts ignited firestorms across entire hemispheres. Supervolcanoes turned the skies black for decades. Each event should have erased them. Each event should have reset evolution back to primitive life. Instead, humans adapted. When the climate froze, they learned to build fire. When predators hunted them, they learned to build weapons. When disasters destroyed their civilizations, they rebuilt them stronger than before. No species in the Assembly archives had ever demonstrated such resilience. And yet, that was only the beginning of the anomaly, because Earth was not merely dangerous, it was chaotic. Its climate could shift violently within decades. Floods swallowed cities, storms tore apart coastlines, entire ecosystems collapsed and reformed again and again. For most intelligent species, stability is required for progress. But humans? Humans seemed to thrive on instability. Their civilizations rose and collapsed in cycles so rapid that many Assembly historians initially believed our observations were misinterpreting the data. Empires would dominate entire continents, then collapse within centuries. Wars would devastate millions. Yet from the ashes, new nations emerged, stronger, more technologically advanced than those before them. It was irrational. Evolution is supposed to reward stability. But human history suggested the opposite. They advanced because of crisis. Their greatest technological breakthroughs rarely came during peaceful eras. They emerged during desperation, during wars, during disasters, during moments when survival itself was uncertain. It was as if the species required chaos to grow. The Assembly debated this for centuries. Many scholars insisted humanity was simply a temporary anomaly, a young civilization still passing through its unstable developmental phase. Eventually, they argued, humans would mature, they would stabilize. All species do. Or so we believed. Then came the Industrial Age. Human technology began accelerating at a rate no civilization had ever recorded. In less than 3 centuries, a blink of time by galactic standards, they transformed from a primitive species bound to their planet into a technological civilization capable of reaching the stars. But the most disturbing detail was not the speed of their advancement. It was the pattern behind it. Each major leap followed catastrophe. World wars pushed technological innovation forward by decades. Global crises forced entire populations to invent solutions overnight. Pandemics reshaped their medicine. Energy shortages revolutionized their industries. Time and again, humanity approached stability. And time and again, something shattered it. Yet every collapse seemed to push them forward faster than before. The more chaos they faced, the faster they evolved. This was when the first whispers began spreading through the Galactic Assembly. Quiet conversations among scholars. Uneasy questions among historians. Because if our understanding of evolution was correct, humanity should have gone extinct thousands of times. But they did not. Instead, they thrived. Which meant there were only 2 possible conclusions. Either the laws of evolution were incomplete, or humanity was something entirely new, an evolutionary strategy the galaxy had never encountered before. A species shaped not by stability, but by chaos. And the most terrifying realization came centuries later. Because humanity was not slowing down. They were not stabilizing. They were not approaching the peaceful equilibrium that every advanced civilization eventually reaches. No. Humanity was evolving faster with every generation, accelerating beyond every model we possessed. And when the assembly finally understood what that meant, a single question echoed across the council chambers of the galaxy. If chaos is the engine of human evolution, what will they become when they reach the stars? And more importantly, will the galaxy survive the answer? Long before humanity discovered the stars, the galaxy had already discovered something else: perfection. It was not an emotion, not an ideology, not even a cultural aspiration. It was a pattern. A universal trajectory observed across thousands of intelligent civilizations scattered throughout the spiral arms of the galaxy. Species rose from primitive beginnings, endured early instability, and eventually reached a point where their societies stabilized into something permanent. The scholars of the Galactic Assembly called it the law of perfect civilizations. It was considered one of the oldest truths in the known universe. Every species followed the same path. In the beginning, chaos ruled their worlds. Primitive governments fought endless conflicts. Resources were scarce. Technology was dangerous and unpredictable. Entire nations could vanish within generations as societies struggled to survive their own rapid development. But time changed everything. Eventually, civilizations matured. Governments stabilized. Economies balanced themselves. Scientific research became cautious and methodical rather than reckless. Wars became rare, then impossible. Technology advanced more slowly, but more safely. Every invention was tested across centuries of simulations before being implemented. Entire committees existed to ensure that no discovery could destabilize the delicate balance of a perfected society. Progress never stopped, but it became controlled, predictable, safe. Civilizations that reached this state could endure for tens of thousands of years. Some had lasted even longer. The Galactic Assembly itself was a product of this law. Its member species had all reached equilibrium before joining. Their cultures were stable, their technologies mature, their political systems immune to the sudden collapses that plagued younger civilizations. This is why the assembly valued predictability above all else. Unpredictability, historically, had always led to extinction. Risk destroyed worlds. Reckless experimentation collapsed economies. Aggressive expansion triggered wars that erased entire species from history. So perfection was not merely an achievement, it was survival. And for countless ages, the galaxy believed this principle was absolute, until humanity forced us to question it. The first time human civilization was analyzed under the law of perfect civilizations, the results confused our most advanced predictive models. At first, nothing seemed unusual. Human history followed the familiar early stages: primitive conflict, rapid technological advancement, unstable governments, environmental challenges. These were common among young species. The models predicted that within a few centuries, humanity would begin stabilizing. Their governments would consolidate. Their global conflicts would diminish. Their technological development would slow as they approached equilibrium. But that did not happen. Instead, humanity did something no civilization had ever done before. They destabilized themselves. Just as their systems began reaching balance, they dismantled them. Economic revolutions replaced entire financial structures within decades. Political movements overthrew governments that had existed for generations. Technological breakthroughs made entire industries obsolete almost overnight. Human society constantly reinvented itself. To the scholars of the assembly, it looked like madness. Why would a species dismantle systems that worked? Why replace stability with uncertainty? One example, recorded in the archives, still puzzles many of our historians. At a time when human communication technology had finally reached global stability, allowing nearly every individual on their planet to share information instantly, humans began experimenting with new systems that disrupted those very networks. The changes created confusion, misinformation, and instability. Entire economies fluctuated wildly. And yet, from that chaos emerged entirely new technological ecosystems, new industries, new methods of communication, new cultural movements. Humans did not merely survive the disruption, they used it to accelerate forward. The same pattern repeated again and again throughout their history. When their energy systems stabilized, they invented new ones that rendered the old obsolete. When their social structures became predictable, they challenged them with revolutions and reformations. When their technologies matured, they began experimenting with ideas that older civilizations had long abandoned as too dangerous. Human civilization never stopped rebuilding itself. Entire societal frameworks could rise and collapse within a single human lifetime. To the assembly, this was horrifying. Most civilizations required centuries to recover from systemic collapse. Humans seemed to recover in decades, sometimes even faster. Their resilience defied every predictive model we possessed. But more disturbing than their recovery was what came after. Each collapse seemed to accelerate their development. Every disruption forced them to invent faster, to adapt faster, to evolve faster. Stable civilizations advanced gradually over millennia. Humanity advanced through cycles of destruction and rebirth, and every cycle made them stronger. The scholars of the assembly debated this phenomenon endlessly. Some believed humanity was simply an immature civilization trapped in endless instability. Eventually, they argued, humans would learn the value of equilibrium. Eventually, they would slow down. Eventually, they would become like us. But as the centuries passed, that prediction began to look increasingly unlikely. Human progress did not slow, it accelerated. Their technologies transformed entire industries within years. Their scientific discoveries shattered previously accepted limits. Their societies changed so rapidly that historians struggled to document the transformations before the next wave arrived. The more humanity disrupted itself, the faster it evolved. This realization spread uneasily through the assembly, because if the law of perfect civilizations was correct, then humanity should have already begun stabilizing. But they had not. Instead, they were moving in the opposite direction, toward increasing chaos, toward faster evolution, toward something the galaxy had never seen before. And that is when a new theory began appearing in the quiet research halls of our oldest universities.
a theory many scholars initially refused to even discuss, because if it were true, then the foundation of galactic civilization itself might be flawed. The theory was simple, terrifyingly simple. Perhaps perfection was not the final stage of evolution. Perhaps it was the end of it. Perhaps stability did not protect civilizations. Perhaps it slowly stopped them from growing. And if that was true, then humanity's endless chaos was not a weakness. It was an evolutionary advantage, which meant something far more unsettling. The species we believed was immature might actually be evolving faster than the entire galaxy. And if that acceleration continued, humanity might reach a future no perfected civilization could ever achieve, a future beyond equilibrium, beyond predictability, beyond the limits the rest of us had quietly accepted. And if that happened, the galaxy would have to confront a terrifying question. What happens when a species refuses to stop evolving?
For most civilizations, the moment of first contact is a celebration. The species looks up at the stars and finally discovers it is not alone. The galaxy welcomes them into an ancient community of knowledge and stability. Their technology matures, their conflicts fade, their place among the stars becomes secure. That is how it had always happened, until humanity reached the threshold. The moment humans achieved faster-than-light communication, an alert echoed through the observation networks of the Galactic Assembly. For centuries, we had watched their development from afar, quietly recording their wars, their scientific revolutions, and their constant cycles of collapse and rebirth. Now they had reached outward. Their signals pierced the interstellar void, and for the first time in thousands of years, the Assembly faced a decision it had long avoided. Should we answer? The debate that followed lasted nearly an entire planetary cycle. Many council representatives argued strongly against contact. Human history, they reminded the Assembly, was filled with instability. Entire continents had fought devastating wars. Their governments were fragmented. Their technologies were often developed through dangerous experimentation rather than careful consensus. One counselor from the ancient Gathari Union summarized the concern with chilling clarity. Humans do not solve problems, he warned. They improvise solutions while the problem is still exploding. For most civilizations, that behavior would be considered catastrophic. Yet, curiosity lingered, because despite their reckless development, humanity had survived. Not only survived, thrived against every statistical model we possessed. Other members of the Assembly voiced a different concern. If humanity truly evolved through chaos, then isolating them might be even more dangerous. A species that advanced so rapidly without guidance could become unpredictable on a galactic scale. Better to observe them closely. Better to understand them. Eventually, curiosity and caution reached an uneasy compromise. A first contact mission would be sent, not to reveal the full presence of the Assembly, only to open communication, to study the species more directly. And so, for the first time in centuries, a diplomatic vessel entered the orbit of Earth. I was among the observers assigned to monitor the encounter. Even now, after centuries of reflection, I still remember the moment we began listening to human transmissions directly. It was overwhelming. Most civilizations speak with unified voices by the time they reach the stars. Their planetary governments cooperate under stable systems. Their scientific institutions communicate through centralized channels. Humanity did none of these things. Thousands of independent voices spoke at once. Governments disagreed publicly. Scientists argued across global networks. Media networks debated every new discovery in real time. To an outside observer, it sounded less like a civilization and more like organized chaos. And yet, within that chaos, an incredible energy existed. Ideas moved rapidly across their world. One scientist would propose a theory, another would challenge it within hours. Entire teams across multiple continents would begin testing the concept before the day ended. Human knowledge spread like wildfire, messy, uncontrolled but astonishingly fast. When the diplomatic vessel finally initiated contact, humanity reacted exactly as our analysts predicted, with confusion. Some believed the signal was a hoax. Others believed it was an attack. Entire governments scrambled to interpret the message. Yet once communication stabilized, the diplomatic exchanges began. And that is when we encountered the most unexpected aspect of human civilization: their creativity. During the early conversations, our representatives presented humanity with limited technological concepts, simple frameworks for understanding galactic physics and interstellar travel. Most civilizations react cautiously to such information. They study it quietly for years before proposing applications. Humans responded differently. Within days of receiving the data, human scientists began suggesting modifications to the theories themselves. They questioned assumptions we had considered foundational for millennia. They proposed combining technologies from completely unrelated scientific disciplines. One particularly memorable proposal involved merging gravitational manipulation techniques with quantum communication arrays. The concept violated at least 12 assembly safety doctrines. Entire sections of the Physics Council had declared such combinations too unstable to pursue. The human scientist who proposed it simply shrugged when informed of those restrictions. "Maybe," he said during the transmission, "but what if the instability is the point?" Our observers were stunned. No civilization had ever spoken about scientific instability with such enthusiasm. More astonishing still was the speed at which humans tested ideas. Within weeks, experimental prototypes appeared in their laboratories. Many failed spectacularly, but not all of them. A few produced unexpected results that our own researchers struggled to explain. The Assembly began sending increasingly cautious responses to human proposals. Certain areas of research were discouraged. Others were politely redirected. Humans interpreted this guidance in a very different way than intended. Instead of abandoning dangerous ideas, they became more curious about them too. Human researchers began digging through our theoretical frameworks, searching specifically for the boundaries we refused to cross. And when they found those boundaries, they asked the same question every time: what happens if we cross it anyway? For the first time in thousands of years, the Galactic Assembly found itself studying a civilization whose greatest strength was not knowledge, not stability, not technological maturity. It was imagination. Wild, unpredictable, dangerously creative imagination. Human scientists were not limited by the same psychological barriers that restrained older civilizations. They did not see impossibility as a permanent rule. They saw it as a challenge. And sometimes they succeeded. The first time one of their experimental designs produced results beyond our predicted limits, the Assembly archives recorded a single observation from the Physics Council, a sentence that would echo through every scientific institution in the galaxy. Human innovation does not follow logic. At the time, many believed that statement was a criticism. It was not. It was a warning, because we were beginning to realize something profoundly unsettling. Other civilizations advanced through careful steps. Humans advanced through leaps, uncontrolled, unpredictable, and sometimes impossibly effective, which meant the species we had just welcomed into the galactic community possessed a trait no other civilization had ever demonstrated at such scale. They could break the rules of progress. And the most terrifying question had only just begun to form within the assembly chambers. At first, humanity's presence in the galactic community seemed harmless. The Assembly welcomed them cautiously, granting limited scientific exchanges and carefully monitored diplomatic channels. Their technology was still young compared to the ancient civilizations of the galaxy, and most council members believed human influence would remain contained. For a time, that assumption appeared correct. Human diplomats were curious but respectful. Their scientists eagerly absorbed knowledge from species thousands of years older. Their engineers studied alien starships like fascinated children discovering ancient machinery. Many observers believed humanity would simply integrate into the existing galactic order. But the first signs of disruption appeared sooner than anyone expected. It began quietly. A small joint research project between human engineers and the Talveri Stellar Navigation Institute, an ancient scientific organization that had spent 3,000 years refining the mathematics of interstellar travel. The Talveri had perfected starship navigation centuries ago. Their systems were flawless, their algorithms optimized beyond improvement. Or so they believed. The human researchers studying their navigation engines asked a simple question. What if the efficiency limits are wrong? At first, the Talveri scientists assumed the humans misunderstood the calculations. The efficiency thresholds had been proven across thousands of test flights and millions of simulations. They were mathematical certainty. But the humans kept asking questions. What if the gravitational compensation fields were layered differently? What if the energy distribution cycles were allowed to fluctuate instead of remaining perfectly stable? What if the system briefly entered controlled instability during acceleration? The Talveri dismissed these suggestions. Instability in starship engines was dangerous, unacceptable. But the human engineers did not stop thinking about the problem. Several months later, they built a prototype. When the test results arrived, the Talveri scientists believed their instruments were malfunctioning. The modified engine was 27% more efficient than the theoretical maximum. For 3,000 years, the galaxy had believed those limits were absolute. Human engineers had broken them in 6 months. At first, the assembly treated the discovery as an anomaly. But then it happened again and again. Across dozens of collaborative research projects, human scientists began producing results that defied established limitations. A joint medical program between humans and the Kalari Biotech Council produced a treatment for a neurological disease that had afflicted Kalari populations for nearly 4,000 years. The cure came from a human researcher who approached the problem from an entirely different direction. Instead of treating the disease itself, she treated the environment of the cells around it. No Kalari scientist had ever attempted such an approach. Their models predicted it would be ineffective. They were wrong. Then came the energy research incident. Human physicists working with the Edron Plasma Collective experimented with a reactor design the collective had abandoned centuries earlier due to instability risks. The humans redesigned the system to allow controlled fluctuations within the plasma containment fields. Every Edron engineer warned the experiment would fail. Technically, they were correct. The first 3 prototypes exploded. The 4th nearly destroyed the laboratory station. But the 5th design stabilized, and when it did, it generated nearly double the energy output of the galaxy's most advanced reactors. The assembly began noticing a pattern. Human innovation was messy, dangerous, often inefficient, but when it succeeded, the results were revolutionary. This alone would have been enough to unsettle the galaxy's scientific community, but something far more disturbing began happening at the same time. Humanity was changing the way other civilizations thought. Young researchers across the galaxy began studying human methods. They were fascinated by the species' willingness to experiment beyond established limits. Human laboratories encouraged ideas that older civilizations would never even consider. They tolerated failure, even celebrated it, a concept almost unimaginable within perfected societies. For most species, failure represented wasted time and dangerous instability. For humans, failure was simply part of the process. Alien students began traveling to human research institutes. They returned home with strange new philosophies. Try first, improve later. Break the rules if the rules are wrong. Progress requires risk. At first, their mentors dismissed these ideas as youthful enthusiasm, but gradually those ideas began spreading. Entire scientific institutions started experimenting with methods inspired by human research culture. Some experiments failed spectacularly. A propulsion project in the outer systems accidentally disabled an entire starport for 2 weeks. A medical study triggered a biological reaction that required emergency containment. The assembly issued warnings. They urged member civilizations to return to safer research protocols. But the change had already begun. Something ancient within the galaxy was awakening. Curiosity. For thousands of years, perfected civilizations had advanced slowly, cautiously refining the knowledge they already possessed. Now they were asking new questions again. Radical questions, the kind that humans asked every day. Not everyone welcomed this transformation. Several assembly members argued that humanity's influence threatened the delicate equilibrium that had preserved galactic civilization for millennia. Risk-taking could destabilize entire economies. Dangerous experimentation could lead to catastrophic technological failures. The galaxy had abandoned such reckless behavior for good reason. Yet other voices within the assembly felt something very different, something they had not experienced in centuries: excitement. For the first time in ages, the pace of discovery was accelerating again. New ideas were emerging, old limitations were being challenged. The galaxy was changing. And while many feared the consequences, others began to feel a quiet, unfamiliar emotion spreading through their societies. Hope. Hope that progress didn't have to end with perfection. Hope that the stars still held mysteries waiting to be discovered. Hope that civilization itself could evolve again. But as humanity's influence continued spreading across the Assembly's worlds, a darker possibility began to take shape in the minds of certain council members. Because if chaos truly drove innovation, if instability truly accelerated evolution, then humanity might not simply change the galaxy, they might transform it completely. And if that happened, the perfected civilizations that had ruled the stars for tens of thousands of years might soon discover something deeply unsettling. They were no longer the most advanced minds in the universe. They were simply the most comfortable. And humanity? Humanity had never been comfortable with limits. Every civilization in the Galactic Assembly believed the same comforting truth. The galaxy was stable. Dangerous, yes. Vast beyond comprehension, certainly. But stable enough that ancient civilizations could endure for tens of thousands of years without facing extinction. We had seen supernovas. We had mapped black holes. We had even survived wars between early interstellar empires. But none of those events threatened the galaxy itself. The stars would outlive us all. Or so we believed. The first warning came from an automated observation station orbiting a dying star near the galactic core. At first, the signal looked like corrupted data. Energy readings were fluctuating far beyond the limits of known stellar behavior. Gravity distortions appeared across entire planetary systems. Radiation patterns shifted unpredictably, as though the laws of physics themselves were bending under immense pressure. Within days, additional stations began reporting the same anomaly. Entire star systems were experiencing gravitational instability. Planets drifted from their orbits. Binary stars collapsed into violent spirals. Energy levels surged and vanished without explanation. The Assembly dispatched investigation vessels immediately. What they discovered terrified them. At the heart of the phenomenon was not a single star, not a black hole, not any known cosmic object. It was a region of space itself, an expanding distortion spreading outward from the galactic core like a slow-moving storm. The scientists studying it called it a stellar consumption cascade, an ancient anomaly that had somehow awakened after millions of years of dormancy. Its behavior was unlike anything recorded in galactic history. Instead of destroying stars directly, the anomaly drained their energy. Stellar cores cooled, fusion reactions faltered, entire suns began dying centuries before their natural lifespans. As the stars weakened, their planetary systems collapsed into gravitational chaos. Planets froze, atmospheres dissipated, civilizations vanished. The first affected colonies were evacuated quickly. Entire populations were relocated to nearby systems. Refugee fleets crossed interstellar space carrying billions of displaced beings. At first, the Assembly treated the crisis as manageable. Stellar anomalies were rare but not unprecedented. Containment strategies existed. Massive energy barriers could redirect cosmic disturbances. Gravitational stabilizers could preserve vulnerable systems. For several months, the Assembly worked with quiet efficiency. Scientists analyzed the phenomenon. Engineers prepared defensive technologies. Refugee relocation networks expanded across hundreds of systems. But then the new calculations arrived, and everything changed. The anomaly was growing faster than predicted, much faster. Its expansion was not linear. It was accelerating. Every star it consumed released enormous gravitational fluctuations that fueled the cascade like a chain reaction spreading through the core of the galaxy. Within 2 centuries, the phenomenon would reach the densely populated inner systems. Within 5 centuries, it would consume nearly half the spiral arms. Within a millennium, the galaxy itself would become uninhabitable. For the first time in recorded history, the Galactic Assembly faced something no perfected civilization had ever prepared for: extinction on a galactic scale. The Emergency Council convened immediately. Thousands of representatives from across the Assembly gathered in the central chamber. Some proposed building massive containment barriers around the affected region. Others suggested abandoning the inner spiral arms entirely and retreating to the outer galaxy. Evacuation strategies were expanded. Refugee networks multiplied. The plans were careful, logical, methodical, and completely insufficient. Every simulation reached the same conclusion. Containment technologies could slow the anomaly, but not stop it. Evacuations could save some populations, but not all. Even the most optimistic projections ended with a grim reality. The galaxy would lose trillions of lives before the crisis ended. For centuries, the Galactic Assembly believed perfection guaranteed survival. But perfection had one weakness: it was slow. Stable civilizations excelled at managing predictable threats. They were far less effective when confronting the unknown. As the debates continued, a single request appeared on the Council network: a proposal submitted by the Human Scientific Coalition. At first, many Council members ignored it. Human researchers had been participating in the Assembly's analysis efforts, but their civilization was still considered technologically young compared to the galaxy's oldest species. But the proposal kept circulating. Eventually, the Council agreed to review it. And when they did, the chamber fell into stunned silence. The human solution was radical. Instead of containing the anomaly, they proposed manipulating the gravitational structure of the surrounding star systems themselves. Massive arrays of gravitational field generators would be constructed around the affected region. These devices would redirect the flow of stellar energy being consumed by the cascade. In theory, the redirected energy could collapse the anomaly inward, forcing it to stabilize rather than expand. It was an audacious idea. It was also deeply disturbing. The plan required manipulating stellar gravitational forces on a scale never attempted before. Entire star systems would temporarily shift their orbital dynamics. Energy levels across dozens of stars would fluctuate wildly. The margin for error was almost non-existent. If the calculations were wrong, the intervention might accelerate the cascade instead of stopping it. The Council chamber erupted with protests. "This is reckless," one representative declared. "The gravitational destabilization alone could destroy entire systems," warned another. "Such technology has never been tested at this scale." Then came the most common objection: "It is too dangerous." And beneath those words lay a deeper concern that many Council members did not speak out loud. It was too human. The proposal embodied everything perfected civilizations avoided: risk, instability, unpredictable consequences. The assembly rejected the plan within hours. Instead, they continued refining their containment strategies. But the anomaly did not care about careful planning. Every year it consumed more stars, more colonies vanished, more refugee fleets filled the outer systems. Entire civilizations began preparing for mass migration. And as the decades passed, the assembly slowly realized something horrifying. Their perfected methods had reached their limits. The models were clear. The containment systems would delay the catastrophe, but they would never stop it. The stellar consumption cascade would eventually swallow the galaxy. And when that realization finally settled across the assembly, silence spread through the council chamber. Because there was only one solution anyone had proposed that might actually work: the human solution. The dangerous one, the unpredictable one, the only one every perfected civilization feared to attempt. For centuries, the galaxy believed chaos was the enemy of survival. Now, survival itself might depend on embracing it. And as the council prepared to reopen the human proposal for consideration, a quiet question echoed through the ancient halls of the Galactic Assembly. If humans' reckless idea failed, the galaxy would die. But if it succeeded, the galaxy might discover something even more unsettling: that perfection had never been the path to survival at all. When the Galactic Assembly finally approved the human proposal, it did not feel like a victory. It felt like surrender. For centuries, perfected civilizations had built their survival on careful certainty. Every technological system was designed with layers of safeguards, redundancies, and centuries of simulation before implementation. The human solution ignored nearly all of those traditions. Yet the assembly had no alternatives left. The stellar consumption cascade continued spreading through the inner spiral arms, devouring stars faster with each passing decade. Entire civilizations had already abandoned their home systems, fleeing outward toward the colder edges of the galaxy. The models had become brutally simple: act now, or watch the galaxy slowly die. So the assembly gave humanity permission to attempt the unthinkable. Construction began almost immediately. Human engineering fleets traveled to the expanding boundary of the anomaly, accompanied by observers from dozens of alien civilizations. Entire research stations were assembled in deep space to coordinate the largest technological project ever attempted. The plan required building a network of gravitational manipulation arrays around the outer edges of the cascade. Massive orbital structures, each larger than a planetary city, would generate artificial gravitational currents strong enough to redirect the flow of stellar energy being consumed by the anomaly. In theory, those redirected currents would force the cascade to collapse inward on itself. In theory. The phrase appeared often in human planning meetings. Alien observers found it deeply unsettling. Most civilizations would never construct such devices without centuries of testing. Human engineers began building them within months. The first prototype array activated while several core equations were still under debate. To the horror of the observing scientists, the system worked. Partially. Energy readings shifted exactly as the humans predicted, but the gravitational distortions also created secondary fluctuations that threatened nearby star systems. Emergency recalculations were performed. Human engineers adjusted the design. The second array incorporated those modifications, and so the project continued. To alien observers, the process looked dangerously chaotic. Design specifications changed constantly. Entire structural components were redesigned midway through construction. Arguments between human scientists erupted across communication channels every day. Sometimes they shouted at each other. Sometimes they laughed while discussing catastrophic failure scenarios. One Kalari observer recorded a particularly unsettling moment during a design conference. A human engineer casually suggested increasing the array output beyond safe parameters. Another human immediately objected. The debate escalated rapidly. Finally, one of them said something that stunned the alien monitoring team. "Well, there's only one way to know if it works." To most civilizations, that sentence would represent unacceptable recklessness. To humans, it was simply part of the process. Despite the apparent chaos, something remarkable emerged from the project: human adaptability. When a simulation failed, they did not spend years analyzing the mistake. They built a new simulation overnight. When a component malfunctioned, they redesigned the entire system rather than attempting minor corrections. Human problem-solving operated at a speed the assembly had never witnessed before. Entire engineering teams worked continuously across planetary time cycles. New prototypes appeared every week, new solutions every day. Gradually, the gravitational array network expanded. Dozens of massive structures surrounded the growing boundary of the cascade, each one connected to the others through synchronized energy fields designed to channel the anomaly's destructive flow toward a single convergence point. The galaxy watched. Billions of beings across thousands of civilizations followed the project through constant updates broadcast by the assembly. Some believed the human solution would work. Many more believed it would fail catastrophically. Because if the arrays destabilized, the gravitational shock waves could accelerate the cascade beyond control. Instead of saving the galaxy, humanity might accidentally destroy it faster. The final activation sequence approached. The completed array network stretched across dozens of star systems, forming a vast ring of artificial gravitational currents surrounding the expanding anomaly. Human engineers performed their final checks. Alien scientists reviewed the calculations again and again. The margin for error remained terrifyingly small. On the day of activation, observation fleets gathered at safe distances across nearby systems. Entire civilizations paused their daily activities to watch the event. Even the ancient members of the assembly, species that had lived among the stars for tens of thousands of years, felt something unfamiliar stirring within them: fear, hope, uncertainty. All emotions perfected civilizations had learned to suppress. The countdown began. Human engineers gathered in their command stations. Some appeared calm. Others were arguing over last-minute adjustments to the system's output parameters. Several alien observers found the scene deeply disturbing. The galaxy's survival depended on this operation, and the humans were still debating design changes. One engineer finally activated the network. Across the void of space, the gravitational arrays ignited. Invisible currents rippled through the surrounding star systems. Energy readings surged across every monitoring station. The massive structures began bending the flow of stellar energy being consumed by the cascade. At first, nothing happened. The anomaly continued expanding exactly as it had before. Observers watched in silence. Minutes passed. Then one of the monitoring stations detected something strange. The outer boundary of the cascade had slowed. Not by much, but enough to register across the sensors. Human engineers adjusted the array's output. The gravitational currents intensified. Suddenly, the anomaly reacted. The expanding region of distorted space began bending inward. Energy flows shifted direction. Stars that had been slowly dying stabilized as the cascade's draining effect weakened. Across dozens of observation stations, the same realization appeared simultaneously. The cascade was collapsing. The redirected stellar energy was forcing the anomaly to fold back into itself. Within hours, the expansion stopped completely. Within days, the distorted region stabilized into a dense gravitational structure resembling a massive stellar cluster. The stellar consumption cascade was gone. The galaxy was safe. At first, the assembly struggled to understand what had happened. Their most advanced models had predicted decades of containment operations. Human engineers had resolved the crisis in less than a week. The explanation eventually became clear. Perfected civilizations avoided risk. Humanity embraced it.
While the assembly spent decades analyzing the anomaly, humans treated it as a problem to solve immediately. They tested ideas quickly, failed quickly, adapted quickly, and eventually succeeded. The galaxy had been saved, not by the careful stability of perfected civilizations, but by the chaotic creativity of a species that refused to wait for certainty. And as the observation fleet slowly dispersed from the former boundary of the cascade, a realization spread quietly through the assembly. Humanity had just proven something no civilization had ever demonstrated before. Chaos was not the opposite of order. Sometimes, chaos was the fastest path to survival. And that realization would soon force the galaxy to confront a future none of its ancient civilizations had ever imagined.
The galaxy survived. For centuries afterward, historians would mark the collapse of the stellar consumption cascade as the moment when extinction was narrowly avoided. Entire star systems resumed their quiet rotations. Refugee fleets returned home. The ancient rhythms of galactic civilization slowly reassembled themselves. Outwardly, the crisis was over. But within the chambers of the galactic assembly, something far more unsettling had begun. Silence. Not the peaceful silence of stability, but the uneasy silence that follows a realization too large to ignore. Humanity had done what thousands of perfected civilizations could not. They had solved a problem the galaxy's oldest scientific institutions could barely understand. And they had done it with methods the assembly itself had once rejected as reckless. For many council members, the conclusion was deeply uncomfortable. The galaxy had been saved, but it had been saved by chaos. Quiet discussions began spreading across diplomatic networks. At first, they were cautious debates between scholars and scientists, but gradually those conversations reached the highest levels of interstellar governance. Because a new question was forming. A question no civilization had ever needed to ask before. What happens when a species evolves faster than the galaxy itself? Humanity's behavior after the crisis only deepened the concern. Most civilizations, after achieving such a monumental victory, would have spent centuries stabilizing their achievements. Committees would analyze every detail of the operation. The technology would be carefully refined and standardized. Humanity did something very different. Within months of the cascade's collapse, human engineers were already discussing how to improve the gravitational array technology. Some proposed increasing its power. Others suggested adapting it for interstellar travel. One research group even proposed using similar systems to manipulate the structure of entire star clusters. To many assembly members, these conversations sounded dangerously ambitious. The technology had barely saved the galaxy, and humans were already imagining new uses for it. Worse still, their society showed no signs of slowing down. Alien anthropologists studying human civilization reported something deeply unusual. Most intelligent species eventually reach cultural equilibrium. Their traditions stabilize, their institutions mature, their technological progress becomes steady and predictable. Human culture refused to do this. Every generation reinvented itself. New philosophies replaced old beliefs. New technologies disrupted established industries. Entire social movements emerged and reshaped planetary politics within decades. To species accustomed to millennia of stability, the pace of human change was almost incomprehensible. Human civilization was not settling into equilibrium. It was accelerating. Even their biology seemed to reflect this adaptability. Humans modified their own technologies constantly. They explored artificial intelligence, cybernetic enhancement, and genetic engineering with an enthusiasm that alarmed more cautious civilizations. Many assembly scientists began studying the phenomenon closely. Their conclusion was unsettling. Humanity did not appear to have a final evolutionary stage. Other civilizations eventually reached perfection. Humans appeared to be evolving toward constant transformation. They were not trying to become stable. They were trying to become something new, again and again. For some civilizations, this realization was terrifying. The traits that allowed humanity to save the galaxy, creativity, risk-taking, rapid adaptation, could also destabilize entire civilizations if applied carelessly. What would happen if humans experimented with technologies that altered space itself? What if they developed methods of engineering stars, planets, or even biological evolution across species? Perfected civilizations advanced slowly because they feared unintended consequences. Humans seemed almost comfortable with them. Within the assembly chambers, opinions began dividing. Some council members argued that humanity's influence should be limited. Their research collaborations could be monitored, their technological experiments carefully regulated. After all, stability had preserved the galaxy for tens of thousands of years. Why abandon it now? But other voices within the assembly opposed those restrictions. They remembered the moment the cascade began collapsing. They remembered who saved them, and they understood something their more cautious colleagues did not. The galaxy had already changed. Humanity's presence had awakened something ancient among the stars: curiosity, ambition, possibility. Younger civilizations no longer saw perfection as the final goal of evolution. They saw humanity, a species that refused to stop changing, a civilization that viewed limitations not as boundaries, but as challenges waiting to be broken. For the first time in thousands of years, the future of the galaxy was uncertain again. Some feared that uncertainty, others welcomed it. But everyone agreed on one truth: humanity was not becoming like the rest of the galaxy. They were becoming something entirely new. And that realization left the assembly with a final, deeply unsettling thought. Every civilization in history had eventually reached its final form, a stable state of perfected equilibrium. But humanity did not appear to have a final form at all. They were not approaching perfection, they were evolving beyond it. And if that endless evolution continued, one possibility became impossible to ignore. The species that once struggled to survive on a chaotic death world might someday become something the galaxy had never seen before. Not merely another civilization among the stars, but the force that reshaped what civilization itself could become. Which left the assembly with a quiet fear none of its ancient members could fully explain. Humanity had already saved the galaxy once, but if they continued evolving without limits, what would the galaxy look like when they were finished changing it? For most of my life, I believed evolution had an ending. Every civilization in the Galactic Assembly believed the same. It was the foundation upon which the galaxy had built its quiet stability. Species emerged from the chaos of primitive worlds, endured centuries of conflict and experimentation, and eventually arrived at a final destination: perfection. A state where societies stabilized, technologies matured, and progress slowed into careful refinement rather than dangerous leaps. It was peaceful, predictable, safe. And for tens of thousands of years it appeared to work. Civilizations endured, wars faded from memory, the stars became a place of quiet cooperation rather than endless struggle. We believed we had solved the problem of survival. But humanity forced us to reconsider everything. The species from the chaotic death world did not follow the path we had mapped so carefully across the ages. They never slowed down. They never settled into equilibrium. Every time their civilization approached stability, they disrupted it themselves. Old systems were dismantled, new ideas replaced ancient traditions, technologies emerged that made entire industries obsolete within a single generation. To the assembly, these patterns once appeared irrational, even dangerous. But after witnessing the crisis that nearly consumed our galaxy, I began to see them differently. Humanity does not fear change, they expect it. Their civilizations are built with the understanding that nothing lasts forever. Governments evolve, cultures transform, technologies become obsolete. Humans accept these cycles not as failures, but as necessary steps in growth. Where other species seek stability, humans seek possibility. And this difference may be the most important evolutionary discovery the galaxy has ever encountered, because stability has a hidden cost. When a civilization becomes perfect, it stops challenging itself. Its institutions grow rigid, its technologies advance slowly, its people become comfortable with the world they have built. Perfection creates peace, but it also creates stagnation. Humanity avoided that fate, not because they were wiser than the rest of us, but because their world never allowed them to become comfortable. Earth forced them to adapt constantly. Storms destroyed their cities, predators hunted their ancestors, natural disasters reshaped their environment again and again. Their survival depended on learning faster than their world could destroy them, and that lesson followed them into the stars. Even now, human civilization continues transforming at a pace the rest of the galaxy struggles to comprehend. Their scientists challenge established theories, their engineers experiment with technologies still considered dangerous by most assembly members. Their societies debate, argue, and reinvent themselves continuously. To many civilizations, this behavior still appears chaotic, but perhaps chaos was never the problem. Perhaps chaos is the engine that drives evolution itself. After all, when the stellar consumption cascade threatened to destroy the galaxy, perfection had no solution. Stability had no answer. Only a species accustomed to uncertainty could respond quickly enough to survive it. Only a civilization willing to experiment with the unknown could save us all. Humanity succeeded because they were not afraid of failure. They were not afraid of change. They were not afraid of chaos. And that realization has left the Galactic Assembly standing at a crossroads unlike any we have faced before. Some civilizations will continue following the ancient path. They will protect their perfected systems. They will preserve the stability that has sustained them for millennia. For them, humanity will remain an unsettling anomaly, a reminder of a more dangerous way of living among the stars. But other civilizations are beginning to see things differently. Younger species, curious minds, researchers who remember the thrill of discovery. They see humanity not as a threat, but as an example. Proof that evolution does not end with perfection. Proof that civilization itself can continue growing long after stability has been achieved. The galaxy now faces a choice: remain perfect or become something more. As for humanity, I no longer believe we truly understand what they are becoming. They are not the strongest species in the galaxy, not the most technologically advanced, not even the oldest. But there is something uniquely powerful about them, something that unsettles even the most ancient members of the Assembly. It is not their weapons, not their intelligence, not their resilience. What the galaxy truly fears about humanity is something far more profound. Humans have no final form. They are a species that reinvents themselves endlessly. A civilization that treats every achievement not as a destination, but as a starting point. Where we sought perfection, they seek transformation. And that difference changes everything. Because a species that never stops evolving can never truly be predicted, never fully understood, never permanently contained. So when the younger civilizations of the Assembly ask why so many ancient species fear humanity, I tell them the truth. We do not fear humans because they are violent. We do not fear them because they are powerful. We fear them because humanity represents something far more dangerous: endless evolution. A civilization that will never stop becoming something new. And in a universe that once believed perfection was the final answer, humanity has proven the most terrifying possibility of all. Evolution never had an ending. It was only waiting for a species brave enough to continue it.